data set we have taken. This data set contains with mask and without mask images. So now there are 350 images of with mask and 350 images of without mask images. So we are going to use this data set to train our model. So now this is the training code we have used. We have imported all the necessary libraries like TensorFlow and Keras to train our model. So here we have loaded our data set here, and we have taken an empty list of data and labels. We have appended all the images into data list, and we have appended all the categories like with mask and without mask categories into label list. So we are and now we have used label manager to convert the categories into convert the categories into zeros and ones. Like with mask as zeros and without mask as one. And now we are going to split the data into train and test. We are going to use train test split method to split the data into train and test. So we are here taken test size as 0.2z, that is 20% of the data will be taken as test data set. Now here we are going to use the image data generator. So is this generally this image generator generates more the image, like it zooms the images, flips the images, rotates the images, and generates more images. So these images can be used for training the dataset. If you have more images, there will be more to learn. There will be more. We can get more accuracy here. Because there are more images to train the model. So we are going to take mobile net architecture. Basically there are many architectures like ResNet, mobile net like this. This mobile net is the best architecture. We are going to we are is the best architecture to train the images in the images here. Other than that ResNet and the CNN, this mobile net is very good. It is faster, so we're going to take mobile net so to train the model. And we are taking mobile net here. And here we are going to, this is the all the parameters. We are going to flatten going to flatten the images, and we are going to dense the images, and we are going to use activation function. So because ReLU activation function works better for in images, the training images, greater in here. And we are going to we are going to use the model dot fit to train the model. So here the training process is to get started. It takes some time because it is there are you should train the data with mask and with mask images, so it takes some time. After training we are going to predict the model here. uh, this is predicting stage. The predicting stage. I'm going to make the classification report. So we have trained the model before, so we have got the accuracy more than 95%, 96%. And after training the model, we are going to save the model in our local disk. So we are going to save. We are going to use this model dot save to save the model. So to save the, we are going to use h5 format to save the model here. And now this is the model. This is the model we have saved here. This is the model, and this model will be loading in our detection face detection go to detect the faces, and send that frames into this model, and detect whether the person is wearing a mask or not. So now we now will go to that Raspberry Pi connections. And now you're going to use putty to connect the Raspberry Pi. So now we'll just now on that Raspberry Pi now. After on the Raspberry Pi, we are going to scan the IP address of that Raspberry Pi. So it takes some time. We are going to scan here. So it shows IP address here. So this is the IP address of the Raspberry Pi. And this IP address we are going to type here 192.168.1.6. This is the IP address, and connect. So it now after connect is successfully connected with Raspberry Pi. Before, now the login ID is Pi, and the password is which I kept. And now this is successfully connected with the Raspberry Pi. This so that's why showing the spied red Raspberry Pi. Now we are going to use a VNC server to connect with Raspberry Pi. So now we are going to use command like sudo VNC server, and we are going to use port 1 here. So sudo VNC server port 1 is we are going to connect in port 1 and click enter. Now the Raspberry Pi is connected. So now we are going to use open the VNC server. This is the VNC server, and this is the VNC. Already I opened here. Again, I'll type here that same IP address. Will type here 168.1.6 and colon 1 is the a port of our server. So now this is successfully connected, and our Raspberry Pi OS is open here. So this is our Raspberry Pi OS, and now if we want to send any data to this Raspberry Pi, we are going to use WinSCP server. So this WinSCP server is used. WinSCP is used to send the images, send the files to that Raspberry Pi directly. So this here we are going to type the host name. That host name is that Raspberry Pi ID only, IP ID only 192.168.1.6, and username is Pi. I'm going to type the password here. Yes, and login here. So we have successfully logged into our Raspberry Pi account. So if you want to send any files, we can send files from here. So I've already sent my files, my Facemask detect file here. So like that we can Facemask detect file. So if you want any file, like if you can send from here. So I'm sending my file. I'll show how to send here. And if you want to send this file Raspberry Pi txt, just drag it and drop here. Okay. And click OK, and the file is transferred. The file will be transferred, and this is the method to use to transfer the files, like this method to transfer the files. So this file is transferred here, and so this is our Raspberry Pi OS, and I have imported all the and trained model in this through WinSCP, and installed all the necessary libraries like TensorFlow, OpenCV, Keras through by Raspberry Pi installation commands in the Raspberry Pi versions. And I will open this um, face detection and the code. And I imported all the necessary libraries like TensorFlow and OpenCV and NumPy. And NumPy, and now I've imported the face detection cafe model. This is the pre-trained model which is used to detect the faces. This is the I'll show this. So this is the face detector. This is the face detector folder in which it contains a pre-trained cafe model which has pre-trained model to detect the faces. Through this pre-trained model, we are going to detect the faces, and send that detected faces to our model to detect the face mask. So we have loaded that pre-trained model through and through CV2 and named it as FaceNet. And this FaceNet we're going to import into passing MaskNet. And this MaskNet uh, we have loaded the model and FaceNet detector model which have created and trained and saved that model. That model we have imported here, and and we are going to start the stream here. And this frame this frame start the stream, and we are going to give the frame size as 850. And and that in that we are going to give location and threads, and this location and threads are came from here. And going to define a function called direct and predict marks. In that we are going to send frame and facenet and masknet. That facenet detect the faces are here, and masknet we have got this is the our model which we have trained. And this after this code will return the faces and learn and with that return the faces and appends the faces and sets the rectangular box over the face this location gives the starting and end point x and y coordinates of the rectangular box appends that and stores that. And that going to return here location and going to return the predict and going to the predict. Here we are predicting faces with mark dot predict, and going to take the faces here from here, and going to predict here and return that the locations and predict here locations of the rectangle box x and y coordinates it will return and predictions. And that location predicts prediction we have taken here, prediction taken here. And we are going to for box we are going to take location, and per prediction we are going to take predictions. And for and if the label is mask, it will show green color box over the face. And if the label is without mask, it will show red color over the face. And it shows it gives the name as with mask or without mask. And after on top of the box rectangular box, it will also show the accuracy of the detection, like how much accuracy it can be, like 95, 98, 99% of the accuracy it will show on the top of the rectangular box. So we are going to show that one also here. And after that it will show the image. After that it will show the image here, show the frame here. See to see it all I am show will show the frame. And if you want to close the frame, now we are going to click q, and then the frames are closed. uh, and c2 dot destroy images all destroys and closes all the windows which we have opened for detecting the faces. All the frames all the stream will be closed. That open camera will be closed after this. So this is the process. And now we'll run this code and see how it is detecting. So here I am using Raspberry Pi 3B plus model. I have inserted SD card with Raspberry Pi OS here in the SD card slot, and the Raspberry Pi is powered with a micro USB cable here, and I have inserted keyboard and the mouse through USB slot here. And I'm not using that VNC server to run this run this code, because there will be huge frame drop and huge lag in that in the stream. So I'm using HDMI cable here so that we can get direct connection, and there will be no frame drop or no lag in the in the stream of webcam. So it is better to use direct connection through wire, so that you cannot get any wire lag here. So here to the camera port I have connected the camera module. This is the 5 MP camera module. I have connected to the camera port in the Raspberry Pi here. So now we are going to run the code. Time to run. So the camera is started and the light blinks here. and then the stream is also started. So so there is no mask here, so it is it's saying that no mask, and accuracy is somewhere around 92, 93, 95%. And if I wear the mask, it shows with mask it shows in green color. With mask, that is 90, 85, 90, 95. It goes on varying according to the frames it receives. So that prediction is not, it will not that only according to the frames it gets, the prediction also changes. See, for different frames, the prediction accuracy percentage will be varying. Like, see, it is varying like this also, 94, 95, 82, 85, like this. And again, if I wear the mask, it shows percentage here, 95% it is showing. So this is the problem.